In our labs last week, we developed different graphs with position versus time and velocity versus time. These two graphs showed two different ways to get two different kinematic equations. In the first graph, we have acceleration and time. This is the line of constant acceleration. To find the kinematic equation, we have to look at the area under the line. So from the beginning to the end is T1 and Tf, which is change in velocity. The area of the acceleration versus time graph is the change in velocity. And since AT is equal to change in velocity, AT is also equal to VF minus VI, which is the final velocity minus the initial velocity. And this leads us to the creation of the first kinematic equation, which is the final velocity is equal to the initial velocity plus AT. In the second kinematic equation, which comes from this graph, we have a slanted line. Up here and down here, we have the different velocity starting points. And like this equation, the area is derived from the area under this line of constant acceleration as well. So the area of the velocity versus time graph is change in x. And change in x is equal to what we can see here, this. You have to find the area of this rectangle and then the area of this triangle. In doing that, we find that x is equal to the initial velocity plus the initial velocity times t plus half of at squared, which is derived from the area of this and the area of this combined. These two graphs that we've helped derive from our different labs last week helped us find the two kinematic equations.